You guys are amazing for being here. When I submitted this talk to this conference, I thought there's no way it's going to be accepted. You know, it's a pretty niche topic already, and especially Bazel. But it's Halloween today, and surprise, we completely changed the title of our talk. So if you're here for the good, the bad, and the ugly Bazel talk, that's going to be in the room, next door. When I was thinking about our Bazel journey, and I was thinking of like trying to find some kind of an analogy, I hadn't actually watched the movie The Good and the Bad and the Ugly, but in my previous life, I had done a little bit of mountaineering. And in fact, this photo was taken from the side of Mount Elbrus, which my dad and I attempted to summit twice. And it was really, really hard, and we didn't make it both times. We were close, but not quite. So when I thought about that analogy, I was like, this is it. This is the analogy for Bazel on Android. But before we go kind of on that expedition, I wanted to start with a little bit of a spoiler. In May of this year, we put an announcement in our Devel Android channel that we're pausing work on our exploration of Bazel on Android. And then one kind of little interesting data point happened. A developer responded to that message, and we kind of announced that we're ramping down all the infrastructure that went along with it. And he pointed out how much he liked the Bazel PR check and the really fast feedback loop that it provided to him. And so we thought, oh, maybe that's a one-off. Let's ask the entire channel what they think. And 10 more people kind of said, hey, let's keep this thing around. And in hindsight, maybe we shouldn't have been that surprised because the numbers we were seeing in CI compared to kind of the Gradle infrastructure that we had running in parallel were pretty good. Our P50 for unit tests, is like running over 45,000 unit tests, running, was under 3 minutes, which was 8.5 minutes faster than the equivalent in Gradle infrastructure. So you might be wondering then, why is this not the subtitle of this talk? Why did we not adopt Bazel? And for that story, we now have to start at the beginning. So when we were kind of looking at this really tall mountain, this is a mountain of K2, so there's a little bit of meta here. But it's a very tall mountain, but we did know that a few companies had gone there and managed to kind of reach the summit. They all kind of used slightly different paths, though, depending on when they started and what kind of tech stack they have. And all of them, we knew, invested a lot of resources, and it was a difficult journey for all of them. So why would we even consider going there? Well, so we were, I guess I should say, I used to work on the developer experience team. Erik is still there. We care about the developers. And consistently, every quarter, we do a developer kind of survey. Developers kept saying slow build times. We just heard the same thing yesterday, I think, in the Q&A with Android leadership. Invariably, it's one of the sort of the most asked, problem areas, I guess. And when build times is a very overloaded term, so when you dig into it a little bit further, what we were seeing in our telemetry in Gradle Enterprise is that incremental build times are actually pretty good when you have Gradle build cache hit, but it's sort of, we see these 10+ minute configuration spikes when your build graph is invalidated, and that's really like where the pain is felt. And that pain is occasional, but frequent enough that developers complain and notice. Sometimes, we see certain build scans where configuration takes 10 minutes. That's just Gradle deciding what it needs to do, and then the build itself, like the execution phase, takes 10 seconds. So now you're taking a task that could have been synchronous to a task that, you're going to go get a coffee while it's running. Just to drive the point home, interviewing one particular developer on our team, I asked, what would make your life better? And he said, I want a machine with 1 terabyte of RAM so I can run multiple instances of Android Studio so I don't have to switch branches. And that's kind of sad. How did we get there? a few years back, we went through a modularization journey on both of our mobile repos, and this is a really good thing to do. I would highly recommend it. It, I think, vastly improved our incremental build times, but we ended up with a lot of modules, and unfortunately, still to this date, Gradle is not good at handling repos with large number of modules. But there is a build system that was built kind of from the ground up to support a very, very large monorepo. And we had adopted that build system on iOS. Things were working out well there, so we thought, okay, why don't we try it on Android? So we joined this party of very small party. Before we head off, just a little bit about the landscape. At Slack, we have a decent amount of scale. It's not huge, but it's also not small. As I mentioned, over 1,000 modules now. We have good layering and build configuration conventions, thanks a lot to the work that Zach has done. And also large matrix of tooling that might go for just the Android ecosystem in general. We have a lot of really cool code gen stuff that we lean heavily into. So, Dagger, Anvil, et cetera, SQLite, Wire, blah, blah, blah. And at Slack, in particular, we take pride in the fact that we're always on the latest versions of tools. So we have, continuous tooling updates. So there is quite a lot of kind of churn in that regard. As with any expedition, we set an initial kind of set of goals. And for us, it was just important that we push far enough that we get good signal on A, does Bazel solve the slow configuration pain? And then B, is it actually feasible for us to do the migration fully? And we were going to just start simple. We were, start kind of Bazelifying our build graph at the lower levels with the libraries, and then move up the build graph to services, features, eventually build the app target, at which point we would evaluate performance and feasibility, and then tackle all the easy stuff, like testing and ID integration and static analysis. All right, and one last thing before we go. We made a decision to not interop with Gradle, so not to put Bazel into our production in CI, for example. That is something that you can do, but since we weren't sure we were going to adopt Bazel, we didn't want to do that. Which means that we would be generating our Bazel build graph from Gradle as the source of truth. That would be the single source of truth, and developers still only had to just maintain Gradle build files. That also meant that initially, at least, we didn't have a blocking PR check with Bazel, so it was fully on us to maintain the system. And that pretty quickly we realized we're going to have to work in a branch because of that churn, constant churn breaking kind of the state of the world for us. So we would, be working in a frozen kind of code base until we got the foundation of building the app target in Bazel. And just coincidentally, that's what Erik is going to talk about next.
Hello, a bit of a delayed introduction. I'm Erik. I admit I'm a bit of an imposter here. I don't identify as an Android developer. My career mostly in the iOS space, though I have worked at 2 companies that migrated to Bazel, so I have a bit of experience and helped out our Android friends on this experiment. Now, when I come in, I like to think about, to build Slack with Bazel, you got to think about what does a build system do? What does Gradle do? And what are we emulating? What does it not do? What is a Gradle plugin? Because clearly, if you're not using Gradle, you're not going to have those plugins. What is Maven? Is that part of Gradle, or is that something else? Did somebody build this yet? There's a whole lot of details here. The theme to kind of hit on is, yes, you can do this, but batteries not included. Kind of a way of saying that prepare to have to build it yourself. So the way Gradle extends the build system is by plugins, and there's an analog in Bazel called rules. So to kind of give you, if you're familiar with Gradle, the way you build an Android app in Bazel is you depend on a few rule sets. Rules Java here is, Bazel's built with Java, so the rule set for building Java is great. It's pretty good at this. Off to a good start. There is rules Android. Please enjoy my AI-generated Excalibur Android figure. This is responsible for resources, Android libraries, Android apps. If you want to take Java code, assemble it into an Android APK, this is the rule set or Bazel rules that will do that. It's okay. Then there's rules Kotlin. Does what it says in the tin. It builds Kotlin. And this is kind of where you get into it's pretty okay, but you'll get a lot of surprises. Things like it builds your Kotlin, but it doesn't support KSP options. And that's where you start to get into, when you go down this route, the customization and last mile kind of comes into play. And then the last one I just want to call out, rules JV external. It's a really weird name. It basically means Maven, external to your repository. But notably, you find out that it's Corsair Maven. Big pain point we had was just minor differences in how the Gradle resolver resolves Maven and how Corsair does it, which is not KMP aware. So off to a good start. Just a very small example of what a rule looks like. This is the first library we built. It's a single Kotlin source file. You pull in the Maven dependencies, Bazel build, the expression of the target, generates a jar. Couldn't be easier. But beyond that, you don't get very far until you realize that there are things you have to do yourself that maybe aren't done yet or maybe are specific to your repository. So the thing I want to kind of highlight here is there's a lot of details. This talk is not a how we migrated to Bazel necessarily in full-fledged, but I want to talk about replacing Gradle plugins. Android Gradle plugin is a plugin. You all know what that is. Rules Android's kind of got that covered for us. Kotlin is a Gradle plugin, I think, right? Rules Kotlin has it covered for us. But we also use other Gradle plugins, SQLite, Wire. We needed view binding, which wasn't supported by the rules already, so we have to go in ourselves, batteries not included, and figure out how to emulate this behavior in the Bazel build system. So to do that, a few preamble slides here about, kind of showing what a Gradle task is. Gradle exposes itself as, you can extend it by implementing a plugin. Plugin is an API from Gradle itself, where you will just override a plugin, implement your apply, and kind of hand waving aside, you'll write code that will take your input, your Java file, and create an output, your class. And this key takeaway here is that Gradle's model is that it's an in-process API invocation. Now Bazel has got something similar. The fundamental unit of work in Bazel is an action, just similar to a Gradle task. It takes inputs, in this case, a Java file. Java, the toolchain itself is the formal input, but it's not implemented or exposed as an API. It generates a set of inputs and outputs and commands in sort of a structured environment, and it'll actually execute a command. That's the big takeaway there, is that Bazel's model is that all actions are external and tool invocations. So, okay, how do you bridge one thing where everything's going on API and another that requires a tool invocation? So a small example here is, again, one of the plugins we use is the AppCache SQLite plugin, great plugin. It's built, if you go into the GitHub repo, it's built on a couple of core libraries inside. It uses the Gradle API, uses SQLite core, uses SQLite dialects. If I want to actually emulate SQLite in Bazel, you lop the head off of that thing. You take away the Gradle plugin itself. You look just at the core libraries, and we need an executable. Wrote our own command line program for basically any Gradle plugin that didn't expose itself as an executable. So now I've got a SQLite command at Slack, and I can generate SQLite by the command line. I don't know, I think it's pretty cool. So the way we do this now is we just wrap it in a rule. Small example here, in the code base, you just call SQLite codegen, pass a few attributes, and just like any other build, Bazel build, my SQLite target, it'll generate a source jar. If you look inside that source jar, you get the same Kotlin files you might see as outputs from the SQLite plugin from Gradle. Really high level, going over off the beaten path here. Corsair Maven versus Gradle Maven, no KMP, we're hard coding the platform coordinates we want. We need to apply KSP options. You got to cherry pick a commit that's not part of the core rule set. No namespace R class support. Oh, friends at Lyft have a commit, cherry pick that, maintain your own fork. We just moved to K2. Well, that's not publicly released in the rule set yet. Oh, but that company has got to cherry pick, pull that in. We're in the game of having a lot of friends, a lot of mediation, a lot of maintaining of custom forks, a lot of really kind of frustrating problems that take a lot of resiliency and knowing what's going on under the covers. So 5 months in, Valera put up the red circle saying we're kind of off track here. We're a bit nervous. This might not hit our targets. And we time boxed ourselves. We said 3 weeks or 1 month, we'll see what we can do. 3 weeks later, we actually got to the point where enough of these barriers were overcome. We were actually building everything but the app target itself using Bazel. So we kept at it, and a whole another 3 months later, finally, my Yay post, where I actually posted in Slack, from Slack, built with Bazel in Slack. Y'all like Slack, right? Last 3 months were tough. Dependency injection, Dagger, Anvil, there were some migrations from CAP to KSP. We were going through a K2 migration. Sugar errors were everywhere. Maven resolution differences. It was like a real pain of just kind of grinding through little build errors and issues until they were all resolved. And so when we had the app building, we kind of stopped and asked ourselves, okay, did we prove anything? It builds. Yes, it's possible. Does it solve slow config pain? Yes, we'll talk about that a bit later, at least on paper. But in a way that matters to developers, do they care? Can we demonstrate a real world benefit? And this will come important later, can we ship a good developer experience using Bazel? So we have to build the whole thing. We have to migrate everything just to know at the end of the day if it's worth it. And that's kind of the realization we had, was you have to build the whole developer experience, soup to nuts, to really know if it's worth it. And I'll go back to Valera for the traverse domain.
Cool. So at this point, as I said, we went through a very long, arduous journey, and we got to the point of actually having that stable foundation where we're building our app target with Bazel. And we cleared all these hurdles, and we're feeling pretty good. But again, now we have to hand this thing off to developers, which means that we can't hand it to them for testing on a really old branch, right? They actually need to do real work with Bazel to get a feel for it, real day-to-day tasks. And for that, we have to be on the main branch. So really quickly, the problem is that we're now 4.5 months out of date since we forked. Since then, we've migrated to Kotlin 2. There's numerous build graph, obviously updates, there are continuous and library versions as well. And so our first attempt here was we thought, okay, we would go kind of slow and steady here and just start to apply kind of rebase, main on top of our Bazel branch with maybe 100 commits at a time. This process was just very slow. The person working on it, we kind of we went at it for maybe a couple weeks, and we thought, okay, at this pace, it's going to take us months if we do this. So we took a different approach. We went the other way, much more direct route. So we took all of our Bazel build graph and tooling in the Bazel branch and plopped it into main, and then see what broke. And here we kind of employed a technique which I highly recommend if you ever explore Bazel. You just do ungodly hacks to just get it to build, right? Something. So we had to comment out some code. There were some duplicate resource problems that Bazel was potentially actually exposing, but Gradle was somehow handling gracefully. And we would just okay, well, this module is not building. Comment it out and keep going. With this approach, we got to a place where we were able to build the app target now with main, with a limited number of hacks, and then we just had to burn those down. And within about a month, we got our first green Bazel build on the main branch. But it's one thing to get one green build on main. It's another thing to stay green on it. As I said, we have a pretty active repo, 200 commits to main per week. Which means several breaking changes. Anytime somebody adds a new dependency in a build.gradle file and that's not synced to Bazel, that's a potential breaking change. So we sort of had to deal with just fixing this stuff up all the time. And as I mentioned before, we were already using tooling to kind of sync from Gradle to Bazel. And the first tool that we used here is an open source Gradle plugin called Aaron. And this plugin is good in several ways. It's highly configurable. You could customize it for your project. And because it's a Gradle plugin, it has access to a lot of the internals of the setup, right, of Gradle setup that we have. So it's, more or less like 100% correct. But guess what? We're using this plugin right when the build graph is changing, so that means it's painfully slow for us to use this at 10 minutes plus every time you run it. So at this point, we thought, well, we can't hand this off to developers and have them use that tool. So, if you look at our kind of like the Gradle file on the left and the Bazel file on the right, you can kind of squint and see that there's similarities. There's a dependency block, then there's basically plugins and configuration. You can kind of like visually see the mapping. So we thought, what if we this was before vibe coding, but we thought, what if we kind of like vibe code this a little bit with a few lines of Python? And so that's what we did. We just wrote a simple script that discovers all the build.gradle ATS files in our code base, parses them, and I use that term loosely because we're basically just doing string matching, and then write them out with a tool that comes from the Bazel ecosystem, Buildozer. Using this approach, we were able to sync our entire build graph in under 3 seconds. So that was pretty amazing. We got really excited about that. And here, we had lots of integration. When the tool runs in 3 seconds, you can stick it, pretty much in a lot of places and have, have a good experience. And so our first attempt, Erik got, super excited and built this prototype using a tool called Watchman, which is a file system watcher. You can configure it to watch for certain changes in a certain folder and basically operate on the changes. And run any arbitrary script. So that's what we did. It was really cool to just see, as you edit the build.gradle file, the Bazel file is basically almost instantaneously updated for you. So we stuck this in a startup action in Android Studio, that would bootstrap Watchman and start kind of like running our sync script. And we thought this is going to be amazing. Then we got a bunch of developer feedback. Didn't work out. It turns out, maybe in some companies you have a very standardized developer setup at Slack. It's not quite hermetic like that. So developers were struggling. Somebody had a different version of Bazel installed. Somebody had Java Home set, to something else, and it was just not working out. Not only was it not working well, it was just actually causing active damage. So computers are hard. We had to roll back. And at the same time, though, we were already working on a tool that would integrate this sync into the PR process. And that works, it's a few lines of YAML, GitHub action. You don't have to read this. It works something like this. Anytime a PR is opened, the GitHub action runs, examines the contents of the PR. If build.gradle files are changed, it will run the sync script, generate the Bazel files, the updates to the Bazel build graph. And then post this message in your PR. You look at the changes. Okay, it's just a bunch of updates. Cool. You merge that PR into your PR branch. You get a green check, and you're good to go. And developers were very satisfied with this flow, so that's what we kept. And now that we had this infrastructure to actually, where developers didn't really have to maintain Bazel per se, it was super easy. It was done in a nearly automated way. We were able to announce that, hey, we're going to flip this Bazel check that you're going to start seeing on your PRs to a required check. And this was a huge milestone for us because now we were no longer stuck in this sort of continuous loop of having to fix the build. We could focus on other important stuff.
All right. So at this point, let's talk about tests, because tests were the point where we were going to maybe see some of the realized benefits of using Bazel, at least in a CI environment. So this is a gentler part of the trail compared to the building from scratch, the app itself. There's KT JVM tests, runs JVM tests with Kotlin. There's KT Android local tests for running RoboLecture tests. So these are things provided already in the rule set by the community. We discover every quirk and wart in our setup along the way. Like, if I go and migrate every single Gradle build file, I find out if you use the wrong RoboLecture declaration. I find out if you have things in non-conventional locations. And the only pain point there was really just going through the whole code base and fixing tiny little knickknacks here and there. But I want to call it, there are two little bits of important bits of batteries not included. Migrating these tests. First is instrumentation tests. there is no rule support for instrumentation tests actively maintained in the Bazel ecosystem, so that was unfortunate. We do use a product called Emulator, WTF, and
Here.
they're here. And I need to thank them here because, okay, I need to write a rule. And if you remember, I need a command line, I need an executable, and they ship one. So thank you for that. I was able to wrap a fairly trivial rule around it. So now I just run Bazel test features, AS summary, semicolon, and named targets WTF because it's more fun that way. And it fits into the Bazel test structure and work avoidance nicely. Caches results, saves round trips to the emulator WTF. At least I thought that was pretty cool. Graph of our invocation differences. The blue line is our Gradle invocations. The red line are our Bazel invocations. And these are all just running side by side, same set of test suites in CI. The reason it's lower on Bazel is because the work avoidance system will look at the actual inputs, the test APK, the script that runs emulator WTF itself, hash those, determine if it's a cache hit or not, and if it is a cache hit, it just skips that invocation altogether. The other one is, again, remember I said I wasn't an Android developer? So this is the one where I feel like the dog on the mountain, where I have no idea what I'm doing. Minor details in how build systems like run tests. The way that the test runner in the rules for Bazel works is it just will run all tests in one JVM. And we have these poly test suites, which will mix Roboelectric and Android tests that use the as default return value. And so what we're finding is that we would run these test suites. If they mix them, the first one would pass, the second one would always fail because it would load whatever class it got to first. And the second one, again, I don't know if you can purge. Again, I apologize. I'm not an Android developer, but I don't know if it can purge these things. So we'd find out ways to let these tests coexist and run. So we do certain things that I had to apologize to our Android developers for, where in our Bazel build files, we literally call out, I call them JVM only test, meaning non-Roboelectric, and actually created 2 test targets. So whenever there's a test project in our Gradle setup, we would actually run 1 Roboelectric, 1 non-Roboelectric for every single module. Aside from those bits, the good news is we were able to kind of see some speed here. This is a pretty typical cold Bazel invocation. I wrote the slide out because it kind of shows what work is being done. So I'm not going to dedicate a lot of time to this, but Bazel builds are by design fully hermetic. What that means is that the build's reproducible from end to end. And in this case, what that means is that even the Android SDK is not something that we have developers manage. It's declared in our build file. It's downloaded. We've hit Bazel build the first time. It actually downloads the Android SDK, puts it into a workspace-specific output directory, and will actually inject that Android SDK environment variable into all of your build actions, right? So that really helps with reproducibility for the cache, helps you control what SDK developers use locally. So when you run on CI, what's going to happen is you're going to see the perf trace is going to download the Android SDK, it's going to download the Maven jars, and it's going to run and build all 555 JVM tests for a unit test. And that takes about 18.5 minutes, pretty similar to our Gradle test for a cold build. We have fun names for our CI agents in Slack. So if you run, a Marvis Lemur once, and it's a cache build, you're going to see most of the build time on a cold Lemur. It's going to be mostly downloading the SDK, downloading the jars, and downloading and checking cache hits. And if you run it on that same one, then the very next time, it'll take a whole 1.99 seconds. For the analysis step is simply that fast. But to give a more real-world example of what a side-by-side looks like, so this is a Develocity or Gradle Enterprise view of our unit test history. The green on the bottom, that's configuration or non-execution time. The top is the execution time. And you can see it's pretty consistent configuration penalty we hit. Now that's about, according to that dashboard, it's about just under 3 minutes. And we hit that pretty consistently on effectively every build. I think the ones you see that are kind of 0, I think those are you just hit the same machine on the same code base. And it just hit that hop from the cache. But across 40, 50 agents, pretty consistent 3-minute configuration time. And so the P50 difference that Valera showed earlier, I kind of have that illustrated to my best ability right here. If you were to run the P50 or look at a P50 test for Bazel, what that's going to look like is a 1 to 5 second loading and configuration time. It's pretty trivial. Then it's going to spend some amount of time building, say 99 out of a 555 tests, and then some time actually running and executing those tests. Now, the time to run a test, a build system's not involved there, it's gonna be pretty consistent between Gradle and Bazel. The difference we see in then the Gradle builds is that first of all, you have that flat 3-minute configuration penalty we hit on basically every build. And then between then, and then like I can actually want to talk to some people in the audience about the details here. There's a mix of Maven resolution, which I think is a bit more consistently done on builds in the CI environment in Gradle, and the fact that our cache is not perfect on our Gradle builds. It's generally a harder problem to keep a cache performant on Gradle. It can be done. As of right now, it's Slack. We do not have consistent cache hits for our test work avoidance. And I know that, and I'm assuming by downstream is that we also have inconsistent cache hits for our actual compilation targets. But the net result is that the typical P50, again for Bazel, just had 3 minutes in the bottom, and then it's 11.5 minutes for Gradle. Missed my slide cadence there. Yeah, we think it's a combination of Maven resolution and cache misses. All right, ID integration. This one we're going to kind of go through fast, but in a fun way. It's complicated. This is where things get a little south. Okay, this is a repository, Bazel build IntelliJ. This is the IntelliJ plugin for building Bazel. It's what most companies use, at Android or not, to use Bazel. But if you know the community well, you know that you don't actually use this for Android Studio. There is a Google branch. You got to click down on the Dropbox. You pick the Google branch. And you'll find this in the README. This branch is deprecated. Only the master branch is actively maintained, so you're already doing a bit of this. Frustrating. Okay, so IntelliJ, there's a main branch, and there's a Google branch. If we're going to compare them, the main branch is IntelliJ. Again, I'm not an Android developer. I don't know how much, if I would give IntelliJ to developers, if they're going to hate my guts, or if they're going to say, this or that, I don't care. But it doesn't have any Android support on the main branch, but it is maintained. Now, the old branch, the Google one, it's old. It is unmaintained. It is built Android Studio plugins, but it's Meerkat earlier. It's old Bazel. You need to patch the rules. It's unaware of all the new rule sets and the changes that have happened, but it has composed previews, which turns out that's a big deal later, and that is why all of our friends use this, because it works, but it's old. And I know I didn't want to go tell our developers, here's this Bazel thing I'm going to throw at you. Please download Meerkat, blah, blah, blah. Okay, so we're going to keep looking. Again, more boring README stuff, but I wanted to highlight that if you look deep enough and you know the community enough, you'll find buried, turns out it's deprecated because it was actually moved to the Android open source project. And blah, 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 something that's synchronized between this branch, magic. Okay, so let's go to the AOSP. Here it is. Yeah, it works. It builds modern Bazel. It has modern Android Studio, even Canaries. But it's not GitHub. It's open source, but it's relatively closed contribution. And kind of worst of all is there's no composed preview support. In fact, because of the changes in Android Studio, you can go to like this stub where there's a literal to-do inside the handler for composed previews in the Bazel plugin. All right, but there is another. JetBrains announced a year plus ago they're rewriting the Bazel integration for JetBrains. They call it Hirschgarten. Cool. One more. EAP. Modern Bazel, it works well. Again, back to the whole IntelliJ thing. Whatever. But composed previews works. The Android features are a prototype. I hear it was all made by one developer who liked to try it out in spare time, but is not part of the roadmap. It's there. Kind of works. We call these the 4 forks. Kind of as a good illustration of where it gets a little bit messy in this ecosystem. With that in mind, let's talk about, we call it the peak to the summit, actually trying to roll this out to developers. Local development preview. Any developer preview needs an IDE. We picked Hirschgarten as our horse. Onslaught of AI-generated images coming your way. So the route we took was we picked Hirschgarten, set up a cache warm ops for IDE sync. So IDE syncs in Bazel. Nice thing is they are all cached, so they can be lightning fast. For developers, 2 infra, 2 UI. We just want them to live with Bazel daily, tell us what they think, get some telemetry, give them a survey, tell them if they like it, indifferent, or hate our guts. And it came off to a rough start. One fell off quickly, just a ton of paper cuts that we weren't able to respond to in time. One didn't get very far after that, and 2 developers stuck with it. The ones that got through, the infra dev. The infra dev in our team, they're the ones doing library work, foundational work. They're the ones who really benefit from, not suffering that configuration penalty when they make a change to the code base at a root level. Loved it. Wanted to continue using it. The feature dev works a bit further down in the stack, uses probably a bit more IDE features for feature development, compose previews. Then they didn't like it. A lot of IDE freezes, slow compose previews, was noticeably slower incremental build times. I'll touch on that later. Sync performance was faster for them, but it wasn't a game changer. It was slow. It was buggy because, again, I mentioned that one developer just kind of did it in their spare time. It wasn't an official product they shipped. It was not officially on the roadmap. And we look at that in a vacuum and you say, okay, well, we're not going to hire or be IDE developers ourselves, which is a pretty big factor into whether we go forward with this or not. So the two blockers were performance compose previews and incremental competency support. I'll touch on that a bit more at the end there. It's kind of a big one. So at this point, we've been working on it for 15 months. These are Valera's pictures. I'm kind of living vicariously through his history. Incremental competency, compose previews, static analysis. The iOS ecosystem, was, again, I'm an Apple developer by trade. That was a bit on fire. I could really use my help. AI projects were knocking at our door. We decided it was time to go home. Wrote the project. Sorry.
No, it's just yeah. I can.
Yeah, talk about the mountain. Your mountain.
No, yeah, it's. I mean, this was a long project. Obviously, I think it's kind of it took us 15 months just to get to the developer preview and learn this thing. And you'll see that also progress is not linear. It went really slow at the start as we were just trying to check all the checkboxes and all the different types of tooling that we needed to support. Then it kind of started moving faster. And then it, again, kind of was a real downer with the IDE support that we did not want to open that can of worms. All right. Take us home, Erik. So
yeah,
we do have
we do have the good, the bad, and the ugly. We'll talk a bit about reflections on the ecosystem and our experiences. Of course, Bazel kind of falls into each camp. The good is, yes, you do get speed everywhere. No configuration time kind of lifts all boats. The cache is easy to maintain and have correct cache. It kind of, the speed element of it, without a lot of fine tuning, it kind of tends to just work. This is a bit of a very example, kind of walk it through the code base, building the app, going 30 commits at a time back in history. The Bazel build times just from a code change, cold cache, was, depending on how far back you go in time, many multiples faster than the Gradle counterpart. Also good, hermetic builds are awesome. This is a whole talk in and of itself. With Bazel, we don't deal with, you don't need to go tell your ops team to install JQ, YQ, and your SDK, the JDK. Java, the JDK itself is hermetically handled by the build system. You just declare you want remote JDK 21. It'll download it from Azul. It'll use that in all of your builds. Any tool you want is all sort of resolved at runtime via network, typically for external dependencies, validated with the SHA-256 checksum. So when you go in CI, you just say, just give me Bazel, and it'll work, nothing else. It is a true polyglot build system. So if you're in a monorepos, if you want to have one build system for both mobile and backend, if you want to mix languages, if you want to have, a good example, on iOS, we have CodeGen with Python. Python then feeds into our source input. That's all done in Situ, in the build. The true polyglot build systems means anything you want to build, it can do, and it can do well. A lot of it's open source for rules, language rules, but if it's not, it's actually not too difficult to write a rule yourself. But then there's bad. Of course, specifically at Android, battery's not included. The community exists, but it is not huge. It's not a big flywheel of contributions. Specific skill sets, differences, and of course, no official support from Google or JetBrains means anything that does not work is kind of your problem. And then the ugly, calling incremental. So this was the big thing that kind of started the end of the project. The best we can do, optimizations all in, was over double the time for a typical incremental compilation flow. It is possible, there is work. The JetBrains folks are exposing the incremental compilation APIs. It can be done in different build systems. I know that friends at Meta have done it with Buck or are doing it with Buck. I attempted this myself. Time-consuming, difficult, and possible, but needs a lot of focus and attention. Our project simply ran dry of our appetite. So, and then of course the contribution model is a bit of a mess. You'll find there's a lot of forks flying around. There's not really an official way of doing things all the time. The IDE story is incomplete. Even a minimal setup requires forks, patches, and you must be involved in the very small community to even survive. Would we do it again? Yeah, maybe for different reasons. Unification of tooling, speed. There's benefits there. It's kind of always a trade-off of investing our time, our energy against the benefits which real perceived are often debatable. But the end. Thank you.
That's all.
Did we have time?
We did.